Gunpowder is one of those things everyone has heard of, but almost no one knows how it's actually made. Why does a simple mix of three everyday-looking ingredients create an instant explosion? Why did ancient Chinese alchemists, while searching for a potion of immortality, accidentally invent the formula that would shape wars, fireworks, and world history? And here's the real surprise: the recipe hasn't changed for almost 1,000 years. Gunpowder might seem like a complex invention, but its entire power comes from just three simple ingredients, and each of them plays a strangely perfect role. 1. Potassium nitrate, saltpeter. It looks like ordinary white crystals, but it holds a hidden talent. It releases oxygen faster than anything in nature. That oxygen becomes the boost that makes the reaction possible. 2. Charcoal. Just burnt wood, but because it's light and full of tiny air pockets, it turns into the ideal fuel. It catches fire instantly. 3. Sulfur. This yellow mineral acts like a shortcut. It lets the whole mixture ignite at a much lower temperature, making everything burn smoother and faster. What's fascinating is that these three ingredients have barely changed in 1,000 years. The real evolution came not from what was used, but how people learned to combine them. In ancient China, the original recipe was simple: grind all three ingredients into a fine powder. But this early mixture had a flaw. It burned unpredictably, too slow one moment, too fast the next. So medieval makers invented a clever technique called corning. They added a bit of water, turned the powder into a paste, and pressed it into solid cakes. When those cakes dried, they were crushed into granules. These little grains solved everything. They burned evenly, produced consistent pressure, and suddenly gunpowder wasn't just a curiosity, it became a reliable force. That single change helped shape everything from ancient cannons to early fireworks. So what actually happens when gunpowder burns? The moment a spark touches it, potassium nitrate releases oxygen at high speed. Charcoal grabs that oxygen and ignites instantly. Sulfur accelerates the entire reaction like a chemical shortcut. All of this happens in a split second, creating a huge burst of expanding gas. That expanding pressure, not the flame, not the smoke, is what launches a bullet, fires a cannon, or paints a firework across the night sky. Gunpowder's real magic isn't the explosion, it's the speed at which tiny particles turn into hot gas. Even though modern firearms no longer rely on black powder, it still survives in surprising places. It powers fireworks, brings history to life in reenactments, fires muskets and cannons, creates controlled blasts for movie effects, and even helps ignite certain fuses. But making it is no casual process. Modern factories use tools that don't spark, carefully controlled humidity, and remote-operated mixers, because the mixture is still as sensitive today as it was centuries ago. From this ancient three-ingredient mix, scientists have now developed cleaner, smokeless, and far more stable propellants. Gunpowder was only the beginning. The science of controlled explosions keeps moving forward. From an accidental experiment with immortality ingredients to a mixture that shaped warfare, fireworks, and chemistry itself, gunpowder's story is one of the most unexpected in history. If you enjoyed this breakdown, make sure to like, share, and subscribe to Simple Things, Surprising Histories. There are so many more surprising stories waiting.